Hello and welcome back. Now, in most applications, you have some data that you want to hold on to, even when the user closes and leaves the app. For example, you might want to store a playlist or an inventory of game items, records of expenses and income, a catalog of constellations, or sleep data over time. Now, in this lesson, you're going to build a sleep quality tracker app and use a database to store the sleep data over time. The app has two screens, represented by fragments. One screen to start and stop tracking, show all the sleep data, or clear all the data, and one screen to select the sleep quality. Here is a quick demo of the app. So you open the app, and to start tracking, you press Start, which records the start time. When you're done sleeping, press Stop to record the end time. This brings up the sleep quality selector. Choose one of those nice smiley faces to indicate how well you slept. Let's say we had an excellent night. You're back to the first screen, and the sleep data now displays. If you want to get rid of all your accumulated data, press Clear, and poof, it's gone. Now, this app uses a simplified architecture with a UI controller, view model, and live data, and a room database. So, what is this room database? Now, in ancient times of computer history, the need for effectively storing and retrieving lots of data arose rather quickly. And with that came the obvious need for getting that data back, without waiting for the tapes or punched cards to be rolled out of storage, located into a reader, and linearly searched to find the relevant data. This was a pain and took a lot of time. So, in the 1960s, the database was invented to speed up data retrieval. Various ways of arranging the data were used, but in the 70s, Edgar Codd invented the relational model. This was subsequently developed further, and many variations were implemented, including by IBM and Oracle. Along with this emerged SQL, a programming language for communicating with databases, and it became a standard for query languages. More recently, object-oriented and NoSQL databases, such as App Engine, have also found their niche. You can learn more about the fascinating history of databases in the Wikipedia article linked in the instructor notes. Now, databases have come a long way. In the past, you needed a big computer with even bigger disks for all that data. Today, it all fits on your mobile phone, with room to spare. This lesson is about Room. Room is a database library that is part of Android Jetpack. Room takes care of many of the chores of setting up and configuring a database, and it makes it possible for your app to interact with the database using ordinary function calls. Now, if we peek under the hood, Room is a database layer on top of the SQLite database. The terminology and query syntax for more complex queries follow the SQLite model. In this slide, you can see how the Room database fits in with the overall architecture that we are recommending in this course. However, for the architecture for this lesson's app, we connect the view model and live data directly with the database. So we're only going to have the outline parts: UI controllers, view models, and a Room database. In this lesson, we assume that you have at least a basic understanding of SQLite databases. After this video, there is a text note that summarizes everything you need to know about SQLite databases and queries for this course. So, in this lesson, you will learn how to use Room to persist data, how to use a DAO, which stands for Database Access Object, to map Kotlin functions to SQL queries, how to expand the architecture you used in the previous lesson to include a database, and how to make sure your long-running database operations don't slow down the app for the user by using Kotlin coroutines. Let's start sleeping.